Okay, good afternoon friends. I am Sachin Solanke, Assistant Professor Mechanical Engineering from Saraswati College of Engineering, Kharghar. So now we have to discuss very important modules from the production process, that is the metal cuttings. So what is metal cutting? First of all, so metal cutting is nothing but the machining. Okay, you have to remove the unwanted material from the workpiece. Okay, the metal cutting is basic elements of the metal cutting is that, okay, there are three basic elements, that is, first of all, draw the basic diagram of metal cutting. So see here, in the metal cutting there are three basic elements. So first one is the workpiece, second tool, and after the machining is to be takes place, the chip will be the forms, that is the third one, chips. So this is the basic elements of the machinings. First one is the workpiece, second chip, and third tool. So this is the basic element of the machinings. So we want to do the machinings. First of all, you have to do the analysis of machinings. So what is the needs of this analysis of machinings? So analysis of machinings is done for you have to calculate the forces induced during the machinings. Second one, for what you first calculate the forces. Okay. For the analysis of machine is required because of you have to first calculate the which types of forces are during the machining. Second, the requirement is that you have to calculate the temperature induced during the machining. What is second one? Temperature. So second requirement is that temperature. The third requirement is that the power consumption of the machinings. Third one is the power consumption. So what will be the power is required, what will the power is gained by the machining during the machinings. And fourth one is the life of tool. This is a very important, that is the life of tools. So for these four parameters you have to done the analysis of machinings. So if you calculate these forces, temperature and power consumption and tool lives, you definitely done the good machinings. So second one, what is the requirement of this machinings? What is the basic criteria of this machinings? Okay, we know, okay, because of the large temperature are induced during the machinings. Okay, the temperature induced during the machining, if is greater than this hardness temperature. What is greater than hardness temperature? That is hot HST. So what is this HST? The hardness temperature. The HST is nothing but the hardness temperature. If this hardness temperature of the tool is greater than temperature induced during machining. If this hardness temperature is greater than the hardness temperature of the tool is greater than temperature induced machining, the machining is to be takes place properly. But if the temperature is greater because of the machining, if the temperature induced during the machine is greater, okay, so what will be happens? Okay, in some cases the tool may be the fails. So what is, you have to clarify what is this hardness temperature. You have to take one small example of this hardness temperature. Okay, you have to see one small example. Okay, so hardness temperature is nothing but the considerable reduction in the hardness of the materials. So what is this considerable reduction in the hardness of the material? You have to say one example. You have to take the one tools. Okay, at one tools you have to see there. Suppose at 100 degrees Celsius, at 100 degree Celsius, okay, the temperature induced at 100 degrees Celsius the hardness of the material is nothing but Rc 65. You have to take one examples. Okay. If you increase more temperature during the machining, suppose you have to take 200 degrees Celsius, 200 degrees Celsius. Okay. Then you have to see that the hardness of the material is Rc 66. So this is the hardness number. Okay, this is the hardness numbers, and hardness is determined with the help of numbers. Okay. So this is a hardness number. Okay. So you have to see that at 100 degrees Celsius the hardness is Rc 65. For 200 degrees Celsius the hardness is Rc 66. If you increase again temperature, that is a 250 degrees Celsius, then we have to see that the hardness is Rc 67. Again we have to increase the temperature, that is a 260 degrees Celsius. So see here, at this case we have to slightly increase the temperatures. Only the 10 difference is there. Only the 10 difference is there. 250 degree and 260 degree. So we have to observe कि Rc is equal to the hardness is a 68. The hardness is a 68. Again you have to increase the slightly temperature, that is a 270 degrees Celsius. Now we have to see the hardness number is a 69. So you have to see that at this position, at the temperature 260 degrees Celsius and 270 degrees, there is a slightly increase in the temperatures, the considerable change in the hardness of the materials. So it is nothing but the hardness temperature of the tool. So one requirement is required during the machining is that the hardness temperature. What is requirement? This one, the hardness temperature of tool. Hardness temperature of tool is greater than the temperature induced during the machinings. Temperature induced during machinings. If this criteria is fulfilled, then definitely your machining is done, is properly done. So if his criteria is reverse, if the criteria is reverse, then the actual machining is to be not takes place. Mean there some be failure of the tools, failure of the machinings is to be takes place. Now you have to see the during the machinings the unwanted material you have to remove. So you have to see now the mechanism of chip formations. So what mechanisms is chip is to be forms. The basic elements of the machining is that you have to see the basic element. Which basic elements? You have to see the workpiece, we have to see the chip, and we have to see the tool. So this is the basics elements of the machinings. So we have to draw for the understanding of the mechanism of chips, you have to draw the very simple diagram. You have to see the very simple diagram. You have to draw the workpiece. This is a workpiece, and now we have to draw the tools. So I like tools draw like this way. So now we have to see the mechanism of chip formations, that is the mechanism. So what will be happen in this mechanism is that when the tool is advances in the workpiece, when the tool is advances in the workpiece, because of the forces, because of the force of the tools, the chip will be the material in front of this rake face, in front of the rake face of the tool. So what is the rake face of the tools? You have to draw the very simple diagram. What is the rake face? So material is goes, see here. What I am saying, when the tool is advances in the workpiece, the materials goes plastically, it will be deformed plastically in front of rake face of the tool. What will be in front of the rake face of the tool? So rake face is nothing but the angle in front of the face of the tools. So it is donated by the alpha. See here, it is donated by the alpha, and this angle is known as a rake angle. So when this tool is advances in the workpiece, the material is get compressed and it is plastically flow in front of the rake face of the tools. So during the again we have to apply the forces to this workpiece. So there is some shear stress is developed. What is it? Which step? Shear stresses. Shear stress is developed. When the shear stress is developed, during the machine, again we have to apply the tools in the forward directions. So one condition is there that the shear stress is greater than the what will be greater than the ultimate shear stress. Ultimate shear stress. When the condition is occur, the shear stress is greater than the ultimate shear stress. So what will be happen? The chip will be the form like a plastically in front of the rake face of the tools. So the mechanism in which the chip formation is to be takes place, and that mechanism is to be nothing but the shearing. Which mechanism? Shearing and tearing mechanism. So on this mechanism, what will be? Chip formation is to be takes place, and that mechanism is nothing but the shearing and tearing mechanisms. So why it is takes place? The shear stress is greater than the ultimate shear stress. You have to see the basic diagram of the stress strain diagram. So you have to draw the basic diagram of stress strain diagram. That is, you have to draw the basic diagram. So shear stress is greater than the ultimate shear stress. And the mechanism in which the chip formation is to be takes place, that mechanism nothing the shearing and tearing mechanism. You have to draw the very simple diagram of stress strain. See when we have to apply the small load to the workpiece. So what will be happen? The stress is directly proportional to the strain, that is known as the proportional limit. Again you have to apply the loads. There is some elongation is to be takes place. There is some matter means elongation is to be takes place in the matter. So what will be happens if it slightly increasing these forces? The stress is increases to this direction and strain is decreases to this direction. So one condition is there, that is the ultimate stress. After that, this ultimate stress, the material is to be breaks. So such condition is same as to this machining, that is shear stress is greater than the ultimate shear stress. So this is the mechanism of chip formation. Now we have to see the during the machinings. There are three types of basic elements, that is a workpiece, tool and chips, and the mechanism in which the chip formation is to be takes place, that mechanism is a shearing and tearing mechanism. Now we have to see the types of chips, means we have to do the machinings. So which types of chips is forms. So now we have to see the types of chips. So during the machining, you have to done the machinings on the workpiece. So the material is removed, the unwanted material is removed. So you have to now see the types of chips. Suppose you have to take one example. So you have to machining the soft materials. You have to take one example that you have to machining the soft material. That is soft material. So we have to draw the basic diagrams. This is a workpiece. This is a tool. and this is the chips. Okay. So, you have to take the soft material and you have to take the basic elements. Okay. When this is the soft materials, the what will be happens in the soft material is that the energy wave propagations or crack wave is absorbed by the materials, means the energy propagation is disappear in case of the soft material. So, how it is disappear? Because of the properties of the soft material. So, what is the property of the soft materials? Okay, because of the what? High toughness. First one properties, see here, high toughness. Okay, because of these properties, because of this high toughness, okay, when the machining is to takes place, the bonds will be the breaks in the form of energy. Okay, the energy wave propagation or crack wave propagation is to be developed, but because of the high toughness properties, this energy wave is disappear in the middle portions. So, this because of this toughness. So, because of this soft material, because of this soft material, the energy wave propagation is to be disappears. Okay. The another properties of the soft material is that the soft material is strong in tension. What is properties? First one property is the high toughness. The second property is what? Strong in tension. Okay. And the third property is that the soft material is a moderate in compression. Moderate in compression. So, definitely this is a ductile material. If you take the example of the soft material, and soft material is nothing but the ductile material. So, this is the ductile material, and because of the mechanical properties of the ductile materials, okay, the chip will be formed in the form of continuous chips. What will be the chip will form in case of the soft material is a continuous properties because of the properties of the toughness. Okay, because of the toughness, what will be happens? The energy wave absorbed by the materials and in the middle portion, and the continuous chip will be the forms. So, now we have to consider assume that what we assume that the in case of the soft material, you have to getting the continuous chips. Which types of chips? You have to getting the continuous chips in case of the soft material. Okay, you have to note this. In case of the soft material, you get the continuous chips. So, you have to see the soft material. Now, you have to see the what hard material. Okay, one is the soft and second is the hard. Now, you have to see the hard material. Okay. Now, we have to again draw the basic elements diagram, that is the same diagram is there. Same, this is a workpiece. This is a tool. Okay, again I say when the tool is advances in the workpiece, okay, advance in the heat is generated, okay, because of the plastic deformations in front of the rake face of the tools. Again, what will be happens? But the main properties of the brittle material, that is the hard material. Hard material is nothing but the brittle material. The brittle material having the very low toughness. Very important. The brittle material having the low toughness. Low tough. Okay, because of this property, when I say the continuous chips, what will be happens? Because of the properties of the hard toughness, okay, the energy wave propagation is absorbed by the material, but it is in reverse in case of what? It is reverse in case of the hard materials. Okay, we take the low toughness, okay, because of these properties, okay, the energy wave or crack wave is not crack wave or energy wave is not absorbed by the materials. It is not disappear in the middle portions. So, material is to be cut into the, or material is to be machining is to be takes place in a discontinuous matters, means the chip will be formed in case of step by step. Suppose first step chip will be formed, again second some condition second chip will be formed, third conditions, see here chip will be formed, see here the chip will be formed in the manner of discontinuous, first, second and third, because of the properties of the hard materials. Okay, the hard materials is nothing but the brittle materials, and we know the brittle material are, what is the properties of brittle material? Strong in compression, strong in compression, first one. Okay, if is strong in compression, definitely there is a moderate in tensile, moderate in tensile. So because of these properties, what will be the hard material is to be happen in case of the low toughness, means because of these properties of the low toughness, the material is to be formed, that is a discontinuous chips. So you have to assume, now we have to assume the discontinuous chips, this is a discontinuous chips, this discontinuous chips is happen is to be produced in case of the brittle material, in case of the hard materials. Okay, now we have to first again in first material, soft material, if you machining the soft materials, we get the continuous chips because of the properties of the soft material. Second, discontinuous chips, we get the which material? We get the discontinuous chips in case of the hard materials. Now we have to see the third one. Third one is nothing but the continuous, that is built up edge, BUE. What is this? Is a BUE. So BUE is nothing built up edge. So what this built up edge? So we have to assume, you know, the during the machinings there are number of microchips or microchips of small particles of chips are produced in the machinings, and because of this small particles, one condition is there, because when this small particle when is exposed to the machinings, when this is exposed to the high temperature, so what will be happens, because of the welding properties, because of the first law of thermodynamics, okay, these high temperature chips, these microchips get adhered or welded in front of rake face of the tools. So you have to elaborate in the diagram. So you have to draw the diagram. Again you have to draw the basic elements. Okay, the built up edge, this is a built up edge. Now you have to see this condition. Okay, you have to see this condition. So what will be happens? A built up edge. Okay, because of the during the machining, the microchips are formed, and these microchips is to be exposed to this atmosphere, the high machining process. Okay, the maximum temperature is to be at these positions. Okay, and these microchips, what will happen? Some conditions, these microchips is welded or adhered to the these tools, and there some be built up edge is to be takes place. So one important point is that this built up edge is to be takes place, but it is happen only in case of the what? It is happen in case of only the continuous chips. So it is remember that the built up edge is to be formed in case of only this what? Continuous chips. So what is the reason? Okay, what is the reason this is happen only in case of this continuous chips? The reason is that you have to see, because of this low toughness, okay, the energy wave propagation is to be takes place and crack way is to be developed, and because of this, okay, the material is get throw away from the workpiece, get throw away from the machining. So because of these properties, okay, what will be the this continuous chips is to be formed only in case of the continuous chips, means built up edge is only in case of the which cases? Continuous chips, because of the properties of the ductile material, that is soft material, and because of the why it is not happen in the discontinuous chips, because of the property of the low toughness. So you have to see, this is the what types of chips. Okay, so मैंने कहा था what I am say, okay, the types of chips is to be formed. First of all, you have to see which types? Continuous chips. Okay, continuous chips is to be happen in case of soft material, and discontinuous chip is happen in case of which in hard material. Now we have to see the process parameter. Okay, there is some standard process parameter. Now we have to take one process parameter if you want to get the continuous chips. Now we have to take the continuous chips. See, you have to get continuous chips. Okay, because for the formation of the chip, the process parameter is very important. What is the process parameter is very important. So you have to take one example. One is a continuous chips. See the continuous chips. What will be happen in the continuous chips? See. Okay. For the continuous chips, okay, if you get the continuous chip, you require the high cutting speed. Okay. The process parameter. Okay. The process parameter for continuous chips. You get the what? You get the what? You get high cutting speed. During the machining, if you want to get the continuous chips, you require the high cutting speed, that is VC, donated by VC. Okay. Then large rake angle. What you require? Large rake angle, that is donated by alpha. What is rake angle? It is the angle in front of face of the tools. Okay. Then what? Small uncut chip thickness, small uncut chip thickness, and definitely if you applied the proper lubrication, definitely the temperature induced during the machining is less. So you require the proper supply of lubricant, proper supply of lubricant. So if you want to this continuous chips, you require this process parameter. Okay, that is high cutting speed, large rake angle, small uncut chip thickness, proper supply of lubricants. So what I am saying, if in the ductile material you get the continuous chips. Now you have to see that the what is the process parameter, what the discontinuous chips. Now you have to see another example, that is a discontinuous chips. Now you see the process parameter required for the discontinuous chips. Similarly, this opposite. Okay, low cutting speed, low cutting, that is VC is low. First parameter, large rake angle, that is a definitely small rake angle, small rake angle. So this is rake angle is very important. Okay, what is the effects of these angles? Affects on during machinings. Okay, the rake angle is nothing but you have to see in the previous section when we see the mechanism of chip formations, the chip will be flow in front of rake face of the tool plastically the chip will be flow in front of rake face of the tools. So the rake angle is very important, it is donated by the alpha in front of machining action. If you want to increase the tool lives, okay, if you want to increase the tool lives, definitely rake angle is greater. If you want to increase the tool life, definitely the alpha is greater. If alpha is greater, what will be happens? Okay, the forces induced during the machining is less. Okay, the power forces reduce, power consumption reduce, and all the parameter is reduced. So this is the importance of the rake angle, why it is required. So in case of the discontinuous chips, we get the small rake angles, and what is third one, large uncut chip thickness, large uncut chip thickness. So this is large uncut chip thickness in case of what? Discontinuous chips. Definitely if you increase the temperature, you cannot provide the proper supply of lubricants to the machining. Definitely what will be happen? So the machining is not to be takes place. So due to the happen improper supply. What is improper supply? So this is a process parameter of discontinuous chips, and this is a process parameter of continuous chips. If you want the continuous chips, if you want the discontinuous chips, what will happen? This is the process parameter. Okay, last we have to see the types of chips. We have to consider that if you take the ductile material, definitely you get the continuous chips. What I am saying last in types of chips, in mechanism of chip formation, if you machining the ductile materials, you will get the continuous chips, and if you machining the soft material, you get the discontinuous chips. So it is totally wrong. The right is that the totally types of chips is formed depends upon its process parameter. If it changes the parameter, like if you change, this is for hard material, and you take this is for soft material. Okay, if you change the process parameter for the particular material, it may be ductile or brittle, definitely what will be happen, the types of chips is formed. So you have to remember one point that if you changes the process parameter, definitely what will be happens. Okay, the important point is you have to remember that if you change the process parameter, then your types of chips also changes. So it is not compulsory, only in case of the ductile material you get the continuous chips, and only the brittle material you get the discontinuous chips. It is totally depends upon the process parameter, which process parameter you have to done during the machining. If you maintain the proper machining process, if you maintain the proper process parameter, you get the desired shapes. But generally, you have to say that generally in case of the brittle materials, because of the properties of the materials, it gets the discontinuous chips, and in case of the soft material or ductile material, we get the continuous chips. So this is regarding the types of chips, and this is regarding the process parameter. Now in next lecture we have to see the heat generations and methods of machinings. Okay, now we have to see the next lecture heat generation and method of machinings. Thank you.